All right, finishing up chapter 5, we're going to be talking about the law of cosines. We've already talked about how we use SOHCAHTOA when working with right triangles to find missing sides and angles. We talked about how we use the law of sines to find missing sides and missing angles. And then today we're going to talk about how we use the law of cosines to find missing sides and angles. Now, the law of sines, the type of triangles that we were working with yesterday were triangles that had two angles and a side or two sides and an angle. Now, when you have two angles and a side, you can either have that side be included, meaning between the two angles, or excluded on the outside of those two. When we were working with two sides and an angle, we noticed that the angle was always excluded, meaning that it was not between the two sides. The two situations that are going to come up today is when you have a side angle side situation, so the angle is between the two sides, or a situation where you're given all three sides, and that's when we're going to use our law of cosines. So a review of the formula for law of cosines is right here. We're going to use angle A, angle B, and angle C, and then little a, little b, and little c. A reminder that little a is opposite of angle A, little b is opposite of angle B, and little c is opposite of angle C. So here's our formula that we have, and one thing that you kind of want to look for is notice that the beginning and the end of your law of cosine here is you have little a and then you have angle A. Now this equation here is going to solve for one of those two things. It's going to either allow you to find side little a or angle A. Well, you might be thinking, well, what happens if you want to find little b or little c? Well, we can just rewrite this formula out. Say you wanted to solve for little b or you wanted to solve for the angle of b. We would then write this equation as b squared is equal to little a squared plus little c squared minus 2 times a times c, and then we'd be multiplying by the cosine of angle b. If you wanted to find little c or you wanted to find angle c, then I would be looking at setting this up of little c squared is equal to a squared plus b squared minus 2 times a times b times the cosine of angle C. And you'll notice that with all of these here, that little a, little b, and angle B, and little c and angle C, it's the beginning and the end of your formula that you're using. So I'm going to go through two examples of how do you find a missing side and how do you find a missing angle using the law of cosines. So first of all, solving a triangle, trying to find a missing side. Here I have a side angle side situation where my angle is between 11 and 5. And so setting this up, I'm trying to find x, which in our case here is little c. So my formula I'm going to use is little c squared is equal to little a squared plus little b squared minus 2 times little a times little b times the cosine of angle C. And what we'll be able to do here is really just plug in everything that we have. I have little a is 11, so 11 squared plus 5 squared minus 2 times 11 times 5 times the cosine of angle C, which in our case here is 20 degrees. Now, if we're trying to solve for c squared, what I can go ahead and do right now is just plug all of this into my calculator. So I'm going to go ahead 11 squared plus 5 squared get rid of that, plus 5 squared, okay, minus 2 times 11 fix this up here, okay, times 11 times 5, and then times the cosine of 20 degrees. So I plug all this into my calculator and I get 42.6338, so on. Now that is equal to c squared. What we have to do now is to be able to solve for c, we want to now take the square root of both sides. So we're going to take the square root of that answer that I just got. So I'm not going to round it off yet. I'm going to take the square root of that previous answer, hit enter, and 6.53 is what I end up with for c. And so there's our missing side. All you're doing is just plugging it right into your calculator, and that's all you need to do. Now, when you solve for a missing angle, it's going to take a little bit more work here. Um, I'm trying to solve for angle C, so I'm going to use that same formula that we just did. Little c squared is equal to little a squared plus little b squared minus 2 times a times b times the cosine of angle C. So we're solving for angle C. That means we're going to plug in information everywhere else. We have all three sides. So I have 5 squared is equal to 9 squared plus 7 squared minus 2 times 9 times 7, multiplying that by the cosine of angle C. Now in this next part here, this is where you need to be slightly careful. I can go ahead and do some simplifying if I wanted to. I can rewrite this as 25. We've got 81 plus 49. And then if I go ahead and take 2 times 9, so 18 times 7, that's going to give me negative 126 times the cosine of angle C. Now, when it comes to simplifying the next part, you have to be careful. We cannot just combine all three of these values here. The only ones that we can put together here are the 81 and the 49. The reason for that, if you had a problem where it was 5 is equal to 8 plus 4 minus 2x, we could not put together all three of these terms here. We could only put together the 8 and the 4. Here you've got the cosine of C that's being multiplied on, so you cannot bring that 126 with it. So here I'm going to get 25 is equal to 130 minus 126 times the cosine of C. If I had 5 is equal to 13 minus 12x, my next step that I would do is I would subtract 13 from both sides. Here we're going to be subtracting 130 from both sides. So 25 subtract 130 is going to give me negative 105. And that's equal to negative 126 times the cosine of angle C. Next, to get cosine C by itself, I'm going to divide both sides by negative 126. And when I do that, I'm going to bring my calculator up. Negative 105 divided by negative 126. I get this decimal, 0.83 repeating itself. I could actually turn that into a fraction if I wanted to. And so I get 5/6. So the cosine of angle C is equaling 5/6 at this point. Since we're trying to find the angle, we're going to go and take the inverse of this. The inverse cosine then of 5/6 is what's going to give me my angle of C. So the inverse cosine of my previous answer, and we end up with 33.6 degrees. Now the nice thing about using cosine and the inverse cosine is you only get one answer from 0 to pi. So we don't have to worry about finding another angle like we did when we had to work through the inverse of sine. So you've got one solution and that's it. That's your only possible angle measure for your cosine. So now that we've gone through how we use the cosine, reviewed that, now I'm going to show you a way of finding the area of a triangle using trigonometry, and we would not have to necessarily go through and find the altitude and know what the base is and draw a perpendicular line, any of that, because if I were to show you an example of that from this particular problem that I have here, you'd be looking at a good 15 steps that you'd need to do, and it just takes way too long of time. So I'm going to show you two different formulas that can be used to help you find the area of a triangle if it's a non-right triangle, and one when you have the situation of side angle side, and also one when you have all three sides that are given to you. The formulas that can be used, and if you're interested, you can look at the proofs and how these formulas are derived into your book, but I'm going to save that time right now. Here, if you wanted to take the area, all it is you take 1/2 b times c times the sine of angle A. And what's happening here is you're really taking 1/2 the base times the height. And your base off of this problem here is that little b, little a. And in this last one here, yeah, so it's either little b, little a, or little c for your base, and then you're multiplying it by its height. And that height is being created by the sine, cosine, and tangent. So here I have a triangle that's down on the right here, which is side angle side, and I want to find the angle, or the area of that triangle. So from all of this, I have little c, which is 20, and I have little b, which is 12, and I have angle A, which is 19. So if I want to go ahead and find the area, I'm going to take 1/2 of little b, which is 12, multiply that by little c, which is 20, and then we're going to multiply that by the sine of angle A of 19 degrees. So put it into your calculator, 0.5 times 12, multiply that by 20, and then times it by the sine of 19 degrees, and we end up with an area of 39.07 degrees. Not degrees, just units, sorry. We said 39.07. And so we have our units squared for our triangle here. So you really didn't have to sit here and try and figure out what the altitude of that triangle is based off of one of the sides. Here we could just use this formula to help us find the area of the triangle. So this works for a side angle side triangle. Then what happens if you have 3 sides that are given to you? We're going to use something called Huron's formula, which again, it's derived into your textbook. So if you're interested in how this formula came about, feel free to take your textbook home and look it up. But otherwise here, there's 2 formulas that go along with this. And the first thing that you have to do is you have to find the semi-perimeter, which is taking the 3 sides, adding them together and dividing it by 2. So if I take my 3 sides here of 13 plus 18 plus 15, I'm going to take those 3 sides and I'm going to divide it all by 2. And what that's going to now do is it's going to give me what the semi-perimeter is. And so here, 13 plus 18 plus 15 divided by 2, we should get 23. And then to find our area, we're going to take the square root of your semi-perimeter of 23. And then we're going to take that semi-perimeter again, and we're going to subtract all of the sides. So 23 subtract 13, multiply that by 23 subtract 18, and then take 23 and subtract 15 from that. So now you have really plugged in your formula, and now it's a matter of throwing this into our calculator. And so I'm just going to go underneath the radical here and simplify that first. So 23 minus 13, sorry. All right, 23 minus 13, then we're going to multiply that by 23 subtract 18. Take that times 23 subtract 15, and I'm going to go ahead and hit enter, and so I get 9,200. And so if we want to go ahead and simplify that, we could either find the exact value of it. Here, if I take that value, I divide it by 400. We can simplify our square root here to end up being 20 square roots of 23. Or you could go ahead and find the approximate value of taking the square root of 9,200, which ends up giving us 95.92. And so it's just 2 different examples of finding the area of a triangle without using the 1/2 base times height formula. So if you have questions on something, let me know. Otherwise, as usual, we'll practice these problems in class.